Okay, good morning, good afternoon, or good evening, depending on where you are. My name is Fernando Gont. I am Director of Information Security at Juno, and I will be doing a presentation on improving the reaction of customer edge routers to IPv6 renumbering events. Okay? So let's introduce a typical, IPv6 deployment scenario, such as, for example, an IPv6 home deployment. In this kind of scenario, you typically have a customer edge router that connects the home network to the ISP network. And typically, when it comes to the protocols that are involved, the CPE router communicates with the ISP network using the IPv6 prefix delegation. And it typically also employs Slack to communicate information on the LAN side. The idea here is that with DHCP version 6 prefix delegation, the customer edge router can get a prefix list from the ISP, and then on the LAN side, it can announce a sub-prefix of the prefix that got listed. Okay? Now, let's think about a problem scenario that, unfortunately, it's quite common. This problem scenario that I will be describing will be focused on the IPv6 home deployment scenario for simplicity's sake. But there are actually other network scenarios where exactly the same problem may arise. So let's consider for a second that the customer edge router is hard reboot. And what am I meaning by hard reboot? Well, somebody just unplug the customer edge router and then plug the router again. What will happen, or what will happen when this customer edge router comes back to life? Well, quite frequently, or in most cases, the router will have no knowledge about what was the prefix that had been listed before. Okay, so what this device will do, it will request a new prefix to the ISP via DHCP version 6 prefix delegation. And from the prefix that gets listed, it will announce a sub-prefix on the LAN side. Okay? Now, depending on a number of factors, the customer edge router might get listed the same prefix as before or a completely new prefix. There are cases where ISPs intentionally list a new prefix in these scenarios. Now, what happens if the customer edge router got listed a new prefix? Well, this new prefix will be announced on the LAN side. But what happens with the old prefix, the prefix that was being used before? Well, if there were any systems that had already configured addresses for that old or stale prefix, that prefix will still be there, and the old addresses will still be there. Now, this obviously introduces connectivity problems, because at the end of the day, what happens is that after, for example, these reboots events that sometimes are called flash renumbering events, you end up with systems on your network using old prefixes, old addresses, and this results in connectivity problems. So what I will do during this presentation is try to describe part of the work that we did at the IETF on this area. When we look at all the work that has been done at the IETF when it comes to these so-called flash renumbering events, we have a few documents that were produced. The first document was RFC8978, which is a document that essentially discusses the problem itself. Like all the different scenarios where you might end up in situations where a router gets listed a different prefix than before, so you end up with local nodes using all the information, all prefixes and all addresses. Then there is ongoing work in the 6-man working group on this document, draft IETF 6-man Slack renum, where what we are trying to do is introduce changes to the Slack protocol such that Slack can, let's say, deal more gracefully with these kind of renumbering events. And finally, there was another RFC, RFC9096, with recommendations for customer edge routers. And this is essentially the topic of this presentation. what this document RFC9096 contains is essentially two things. On one hand, it contains recommendations for, let's say, vendors, producing customer edge routers, because in a number of areas, there is, some room for the vendor, to do things one way or another. So this document provides recommendations on how to get things right, such that, to the extent that is possible, this problem is mitigated or minimized. On the other hand, the other thing that this document RFC9096 does is to provide advice to network operators when it comes to how to set or how to configure different protocol values, timers in particular, such that this problem that we are describing here, can be mitigated. So let's look essentially at each of the requirements that RFC9096 introduces, okay? As I mentioned before, some of the requirements could be, let's say, applied or complied with operationally. So that means you could have a customer edge router that, predates this RFC, but still, via the configuration interface, you might be able to tweak some, protocol parameters, which, might be of a lot of help to try to reduce the impact of, the problem that we are describing here. On the other hand, I think that this document is a lot of value in cases where, you have RFPs and, you want to purchase devices, you are, aware and concerned about this problem. So you can, point your vendor, to this document and, ask them to implement these requirements that the IETF has produced. So let's jump to the requirements themselves. So the first requirement is about customer edge routers not doing DHCP version 6 releases. And what is it all about? Well, you have devices that when, for example, the user or the operator does a graceful device reboot, and this would be obviously via, for example, a web interface to the device where you select the reboot option and the device shuts down and then, reboots, as opposed to like, let's say, a more abrupt reboot where you just unplug the device and, you plug it again. Some devices in those scenarios where you do a graceful reboot, they send a DHCP version 6 release message to the ISP, okay, prior to the reboot event. Now, what this means in practice is that the device is essentially telling the ISP, look, I'm not going to use this prefix that you had listed before, okay? So it's free for you to use with any other client. Now, the problem with sending DHCP version 6 release messages is that in most cases, if you do a DHCP version 6 release, if you send a DHCP version 6 release message and afterwards, you ask the ISP for a new prefix, most likely you're going to get a different prefix. So by sending a DHCP version 6 release message, essentially you are introducing, a renumbering event that could have possibly been avoided. So, in summary, the requirement here is that devices should send DHCP release messages when rebooting. The user might have the option to, change the prefix, which could cause one of these messages to be sent. But the idea is that the reboot event should not, elicit one of these DHCP release messages. The second requirement has to do with the interface between the WAN side and the LAN side, okay? There are some devices that, for example, they request a prefix on the WAN side, they get a prefix list, let's say for 5 hours, but then when they have to announce some prefixes on the LAN side, they use lifetimes that span past the lifetime of the original prefix, okay? Obviously, this means that your ISP is leasing you a prefix and is guaranteeing that you will be able to use that prefix for, say, 5 hours. But if you're announcing the sub-prefixes with a longer lifetime, then in between, the ISP might change your prefix, and then the lifetime that you are announcing on the LAN side might be might become invalid. So the requirement here is quite simple. The lifetimes that you use for the prefixes on the LAN side, both for Slack or DHCP, if your network employs DHCP version 6 on the LAN side, must never span past the received lifetimes on the one side. Okay, so if you get a if you get a prefix list for say 5 hours, then the lifetimes on the LAN side should be 5 hours or less than that. Third requirement is the LAN side options lifetimes. Okay, normally when it comes to IPv6, you have customer edge routers announcing a variety of network configuration parameters on the LAN side via Slack. Okay, and many, if not most of these options have an associated lifetime. Many implementations use the default values or hard-coded values for the lifetime values. But when you really think about it, for many, if not most or all of the parameters that you might possibly announce, they are somehow tied to the lifetime of the prefix that you have been listed. Let's consider, for example, the case of the address of a recursive DNS server. Okay, there is some relationship with the recursive DNS server that you might want to use, depending on what's the prefix that you are using for your addresses. Okay, so if the addresses that you are employing for your network essentially change, well, then you should probably consider also changing other network configuration information that you might be using. So the associated requirement here says that the options that you use on the LAN side, whether with Slack or whether with DHCP version 6, should never pass the receive DHCP version 6 lifetimes on the one side. Or as an example, if, for example, you got a prefix list for, let's say, 5 hours, any options that you advertise on the LAN side, for example, with Slack, should have lifetimes smaller than 5 hours. Okay? In this way, you make sure that, if eventually the prefixes become stale, well, then also the other information becomes stale and you have a chance to, renew that information. The next requirement is about signaling stale information. So if you think about the problem we are dealing with, essentially the problem is that, you have your customer edge router, announcing information on the LAN side. Now, eventually, the information somehow it becomes stale. For example, the device was reboot, and now your ISP has listed you a different prefix. And the problem is that in many scenarios, there's no device in the network telling the local nodes, look, information has changed. You have to remove the old information, and you have to use this new information that I'm providing here. Now, one of the key challenges associated with signaling stale information is that, for example, when it comes to customer edge routers, in many cases they don't really store the information that they receive from the ISP on stable storage. To put things in a different way, you have a device, it requests a prefix to the ISP, it gets a prefix list from the ISP. Now the device gets rebooted. And once the device has rebooted, it has no way of knowing what was the prefix that was being used before. So it receives a prefix from the ISP, and it's impossible for the device to tell whether this is the same prefix as before or not. So what these requirements suggest is that to the extent that is possible, the customer edge router or whatever router that you are using stores information that is received from the upstream on stable storage. And if it's possible, for the device to store the information on stable storage, if the device, gets rebooted, for example, or the device somehow detects that the information has changed, okay, the device should announce the new information, with the normal, lifetime values, but it should also announce or advertise the old information with a very small lifetime values, for example, possibly 0. The effect of this will be, of course, that on one hand, you will be announcing the new information with normal lifetime, so that information will propagate in the network. But on the other hand, you are announcing the old information with a lower, for example, 0 lifetime, which will cause any systems on the local network to essentially deprecate or eliminate that information, okay? And finally, the final requirement that this document has is that the bottom line is that besides all of the other considerations that we have made during this presentation, if you look at the lifetime values that are currently employed by Slack, it's very easy to tell that they are inappropriate. Okay, for example, when it comes to lifetime values that are employed for network prefixes, that are employed for address configuration, there are essentially 2 lifetime values involved: the preferred lifetime and the valid lifetime. Okay, the preferred lifetime essentially specifies the period of time during which you can use these addresses configured for this prefix, for issuing, for example, new connection requests. Okay, for establishing new communications. Whereas on the other hand, the valid lifetime specifies for how long you can use the addresses, meaning an address might be preferred and valid, meaning you can issue new connections for that address, or it could be, for example, not preferred but valid, meaning you cannot issue new connections with that address, but you can continue communicating with any existing connections that you might have. Now, the default values as specified in the Slack specification are 7 days for the preferred lifetime and 30 days for the valid lifetime. Now, if you think about this for a second, the implications of these lifetime values are as follows. The valid lifetime essentially means that if a router announces a prefix, sends a packet like a router advertisement, okay, with a valid lifetime of 30 days, then even if the router doesn't announce that prefix anymore for the next 30 days, nodes on the local network will be able to continue using the addresses that they configure for this prefix, okay? So there's obviously a trade-off here, okay? On one hand, you want to use, short lifetime values so that, if network configuration information somehow becomes stale, well, you don't really have to wait for, say, 30 days for the information to get discarded, okay? Now, on the other hand, you want lifetime values that are long enough so that if there's any transient, problem, then, communications can still survive. For example, if somehow, by mistake, you unplug a switch, so now the network became partitioned, you don't want, the prefixes and the addresses to, just time out and, become deprecated and eliminated, but you want to be able to essentially survive those kinds of, transient network failures. Okay, so what are the values that we recommend in the RFC? So we recommend these 2 values, which, as you might see, are very conservative, still very conservative. So for the preferred lifetime, we recommend a default value of 45 minutes. This is compared to the 7 days value that we have in the Slack specification nowadays. And for the valid lifetime, we recommend a default valid lifetime of 90 minutes, as opposed to the 30 days that you have in the Slack specification. So you might see, it's easy to see that we are proposing a very big reduction in the lifetimes that are employed. The bottom line here is that, for example, for the valid lifetime, even if information changes and there's no way to signal the stale information or the change of information to the local nodes, in the worst case scenario, if your network will not operate with stale information for longer than 90 minutes. Okay. So some conclusions, regarding the materials that we have covered in this presentation. First of all, we analyzed mitigations to a problem that has been documented in RFC 8978. There was a lot of work or a lot of a lot of energy that took that project because there were like the people that were arguing that the case of flash renumbering events wasn't a case that should be supported by the protocol. So if somehow your network was renumbered, okay, that's that's a problem that you had to live with. But eventually we were able to publish RFC 8978, discussing the problem, the different scenarios where this problem might arise, etc. We also have nowadays, a new RFC published earlier this year, RFC9096, which contains two things essentially: requirements for customer edge routers and operational best practices, if you wish, with recommendations on how you could possibly tweak some network parameters to mitigate, the effects of flash renumbering events. So I would say, or I would argue that this document is useful. That the usefulness of this document is twofold. On one hand, if you are a network operator, please take a look at the recommendations on how to set these network parameters, which might allow you to deal more gracefully with these kind of scenarios, even if you are using network devices that predate this RFC. On the other hand, if you have any upcoming RFPs, this document RFC 1996 might be a good document, to point your vendors to, so that they implement these recommendations. So far, this has been the presentation, and now we have times for Q&As.
We maybe have time for just one or two questions. I'll take them online very briefly. We have one question from Blake Willis, who asks if you're aware of the IETF work that's been synced up with the efforts of, hopefully pronouncing last name Zoras, to produce our RIPE 554 BIS for device specification document. Is that something you can comment on?
Yes, actually, Jan Source is one of the co-authors of all the work that we have been doing, of the program statement, the operational recommendations, and the update to the Slack protocol. Essentially, the RIPE document, what was recommending was to use stable prefixes, but there are multiple reasons that for edge routers, but there are reasons for which in some cases that's not applicable. And so what we are trying to do is, from different angles to try to improve the situation. But yeah, the RIPE document is aligned with this work that we are pursuing at the IETF.
Thank you. And one question from the mic, and I'm sorry for the people online. I know you have a couple other questions, but we're going to have to move on. I'm blame it on your crummy moderator. So go ahead, please.
Thomas Florian from Data Hive. So in your presentation, you focused on Slack on the LAN side. Does it apply the same way for DHCP v6 on the LAN side? Does it face the same problems?
Yes, exactly the same problem.
Okay. Well, let's give you a round of applause for both talks. Thank you very much for presenting here, Fernando.
Thank you.